That's a very good question. And this is one of the things I've been talking about in Poland for like 6 years or so. And one of the things that I've noticed is that people mislead themselves with the fact that technology transfer is not a brokerage activity. In other words, it's not like a real estate that will sell you or offer you to rent a house. You say, I have a house, I want to sell it, or so I put two together. Technology transfer is a way of doing this business, of transferring knowledge from, for example, the university, whereby the university is not in a position to develop a product, to commercialize it, to market it, to produce. So you transfer the knowledge, you transfer the technology, you transfer the IP, the intellectual property, the patent, to somewhere else who can do, is capable of doing it, like a big company or a small company, a startup company, but they will take care of the commercialization, full commercialization, from the moment they get it to the moment they have a final product on the market. This is technology transfer, and people, unfortunately, don't really follow this definition. Of course, I can compare it. I must admit that I was the deputy managing director of the most important technology transfer company in Israel. It's called Udziela, of the Weizmann Institute. And I was there for 4 years, during 1987 to 1990, or 1986 actually. But the point is that this was almost 30 years ago, and the technology transfer was on very, very early stages, infancy stages, where we have developed concepts how to do it, especially when it comes to university. Because when you're working in university, you're working with scientists that are dedicated to science. They don't have in mind business. They want to publish, they are teaching. Now, sometimes they might have a project or an idea or results that can have a commercial potential. They don't know that. It's hard to know that. Even experienced people don't know if there is a commercial potential, because the fact that it's working in the laboratory with the mice or with the in vitro, it doesn't mean that it can be product at the end of the day. And I can explain about that. But the fact is that you need people who have scientific background, who understand the market, who have some experience with the industry, how to deal with them, how to negotiate with them, and look in the campus for ideas, for projects that might have a commercial potential. Now, once you have such a project, what I like to call is you package it in a way that you can present it to the industry. Now, how can you do that? You have, first of all, to make sure that there is a market, that it is really novel, it is new, that you can protect it with by patent. So the potential industry will have protection, will be the only one to use the technology, sort of a monopoly, which is, it is fine to be a monopoly when you have IP, as opposed to antitrust and stuff. That's not, I will not talk about that at this moment. So you need to package this. To do that, you have to develop techniques how to do that. I mean, how to package it. And this is what we've been doing and successfully doing, because you may know, and I will tell you in any case, that in those years there were some drugs, or actually there were only research projects that has been running at the Weizmann Institute. And two of these projects, at least I'm mentioning now, they became blockbuster product. Like one of them is Copaxone, which is sold by Teva, and the other is Rebiv. Both of them are, by the way, for multiple sclerosis. These two drugs together sell, the annual sales of these two drugs, it should be approximately maybe $5 billion. Just two drugs coming out of the vitamins. It's not on, there are more, but I'm just mentioning those as an example. And now, that could be achieved only if we were able to license it to a company that is capable and competent to develop this product all the way. And it took maybe 10 years to develop this product. Now, the other thing is that in return for giving the license, for granting a license, these companies are paying royalties, a certain percentage of their revenue, back to the university. Now, this is a big amount of money that comes back to the university that can be used to be reinvested in science, to be reinvested in new projects, and so on and so forth, and but only part of it. Normally, the revenues, the royalties, are split between the university and the scientist. So the scientist gets about 40% of this money. So it's an incentive for them to collaborate with the technology transfer company, and it's good for their reputation, and they keep their science. The science is still working. So they keep their laboratory, they have money for the laboratory, and they have money for themselves and their family. So this is the experience in Israel. Just an example. I have an entire lecture just discussing these aspects, but of course in a short interview we cannot go into that. But I hope I gave you I made my point to demonstrate the activities of technology transfer in Israel as opposed to other countries. Not all of the countries have this capacity. Of course, one of the important things that I should point out is that you need to have excellent projects. You need to have excellent scientists. You need to have the competent technology transfer companies to do these jobs. When you have all this together, success is only a question of time. Well, this is a combination. Number one, you have to have a entity in campus, in the university, which be responsible, which be in charge for this technology transfer. So once you have a TTO, or technology transfer office, with competent people that can do the job, they will actually select the project, and they will have to introduce them to potential investors, entrepreneurs, companies, and so on. This is the first job. Once you have this in place, companies will come to you, to this TTO, because they know they are professional. The project that they have been already evaluated to a certain extent. Not every project that every scientist thinks that is a great drug can become a drug or can become an algorithm commercially. So it's not limited to drugs or bio. It could be mechanical, medical devices. Me personally, I had a company, I started a company as an entrepreneur, a medical device company. After I resigned from Yeda, which developed a device for treating, or actually I wouldn't say treating, but assisting paralyzed people to get hand function. And this company started from scratch from a project from university, another university, not the Weizmann Institute, Ben Gurion University. And this company was at the end of, after I think 15 years, 16 years, was acquired by an American company. So this is the entire cycle where you start a company, develop a product, and you sell the company. Or even expand it, but in this case it was right strategically to do it. So you see, you need a combination of this understanding, of this experience, of this knowledge in order to be successful in the next time. Well, let me put it this way. I will talk about mainly the most problematic or most difficult field is the pharmaceuticals. Because at the university, what you will have is an idea, a molecule that can do, work in vitro, you can get nice results with mice, but it's far away from being a product. And the way to go to a product, you have to go to some studies to demonstrate that it is efficiently activities as well as its toxicity or toxicology. and it doesn't harm the patient, and it particularly treats the patient. That's a long process, very costly. It could cost $800 million. Could take 10 years. Now, to convince a big company, pharmaceutical company, you cannot do it with a startup. You need a big company with $800 million. To convince them to get into this very early stage at the university, it's very complicated. Normally it will not work out. What can be done is to take this project to one or two further steps forward. For example, to get some money from the government or from other grants, like you can get it in Poland from the EU grants and so on. And go to a stage where you show, for example, complete preclinical studies. You complete the first stage, which is less expensive. Now, when you come with something that has been proven to be feasible in the lab and passed the toxicology test, it will be more interesting for a big company to look into it and to take to continue to take the risk. So this is, I would say, this is the extreme case where it's hard. But of course, medical devices are easier track. It's an easy track because FDA's or the regulatory requirements are different. The amount of investment is different. Money required is different. So here are two examples in the biofield, the life sciences. Of course, in mathematics and algorithms is different, or in mechanics or engineering and so on. In my views, there are several criteria that should be taken into consideration. It should be really, really innovative in terms of novel and unique, and the market with $1 billion and a competent company that can take it all the way. And this is not easy to find nowadays. Such projects are not. And the ones that are available, and you see them in the United States, some of them are, you can see in Israel because there are new drugs developed in the last decade or so. In the States, obviously, you see more, is the result of the excellence of the scientist and the amount of money invested in this research. Because you need this combination of excellence and funding. Excellence alone is not enough. Funding alone is helpful, but it's not enough. Well, venture capital will not invest directly in a scientist because the mandate is to invest in a business. And in order to invest in a business, what can be done, for example, is to have what we call spin-offs companies. So the scientists, together with the TTO, found a startup company, a spin-off company, whereby the entire project is transferred to this spin-off company, and then there are good chances that a VC will invest money in this company. It could be through an incubator, for example, to facilitate this stage, because you can receive grants from the government. 50% of the money is given as a grant, and the rest should be matched. And this is a very important factor, because when you have to look for 50% matching, you have to work hard, and you keep this money better than you get 100% grant and no accountable if you lose it or not. TTOs should include or hire or retain competent people for this job of technology transfer, which, as I have defined earlier. You cannot have people with no experience. You can have a scientist that can prepare some scientific work and write things, but you need people with experience from the market, that have been down there. They have negotiated deals with big companies. They know how to raise money. They know how to present a project to a big company. They know how to look for the business opportunity in the campus. So you need, and this could be one person, but it's hard to believe. It should be a team that can do this job together, as well as, of course, having a patent protection. So you need to work closely with competent lawyers and patent attorneys, because the license deal transaction itself is very complicated, and you need knowledge and experience. And I keep saying that again and again in this interview, because I see it as very crucial, of how to deal from a legal point of view on a licensing transaction. It's not obvious. It's not like buying a house or renting an apartment or anything of this kind of business that people are familiar with. It's completely different. Well, young scientists, if the system will work properly, they must go through the TTO. But I will give them an advice. They can try talking to people, investors, entrepreneurs, collaboration with them, and interest them, and let them help the scientists if they are capable, because you have to choose, a partner always. It's not an easy thing. And together then, if they go to the TTO, and the TTO will accept this entrepreneur or middleman, whoever we're talking about, could somehow be helpful to promote their project. This is sort of a bypass, but it's a sort of accepted, because it will have to go at the end of the day through the TTO. You cannot bypass, and you should not bypass. To make this project successful, it's not an overnight one thing to do, and here we are successful and millionaire. It works with maybe some applications to smartphones or some Facebook or some. This is different. You can think of a concept, you can develop it quickly, and if it's a good one, it will be very successful, and you go to NASDAQ in no time. But not when you come to life sciences, not to pharmaceuticals, not to medical devices. It's not an overnight operation. It's a long process. You need patience, you need the right partners, right people, enough money, and above all, a good project. But I would not be discouraged about that. What I would emphasize here, it has to start somewhere. So if the project is good, you will find the money if you have the right people to work with you, to assist you. This is almost a rule. A good project with the right people must be successful. Now, not all the projects are as good as one would like to see. So the other way to deal with that is to have the TTO people to be capable, to be competent, to identify the business opportunities, and not every and each project that appears on their desk should be accepted automatically. Say, no, thank you very much. This is nice, but we cannot commercialize it. If you end with 5 projects per year, and you market one of them, you commercialize one of them, and this one will have sales of $5 billion per year, it's not too bad, is it?